So yeah, I'm gonna talk to you about a little thing called that I've just given the generic name of TR-06FAIL. It's about that and other CPE configuration management disasters. So there's a bunch of stupid ISP jargon that I'll explain in a bit, because the people who invented the terms and the people who invented the technology that I'm playing with are a bunch of glue-sniffing monkeys. So who am I? I'm a security researcher at Zyphos. I do a bunch of research and pen testing and stuff. I've had a lot of fun poking embedded devices, just dicking about with them, finding bugs in them and stuff. Before this, I was a forensic student. Before that, I was a pharmaceutical student. And before that, I was like a miscreant in the internet causing a bit of havoc. And I absolutely fucking despise XML. Which sucks, because this entire talk, we're living in the land of XML and crap and disgusting soapy things. So yeah, what I'll be talking about today is we're going to talk about TR-06FAIL, 069. They're both shit. They're basically soap. 064 has 06FAIL, 069 has misfortune cookie and a bunch of other crap. We're going to talk about hacking ACS servers, take over ISPs, taking over the world and all that, and a bunch of other related gubbins in no particular order, because I can't organize slides for shit. So, there'll be a somewhat logical progression of thought here, but yeah, it'll make sense eventually. So, before we begin, I'd like to point out that prior to me writing this talk, there was some amazing research done. There's a chap who used to work at Checkpoint, Shahar Tal. He did some awesome work, discovered the misfortune cookie bug, gave an amazing talk about hacking ACS servers at DEF CON called I Hunt TR-069 Admins. I was lucky enough to see his misfortune cookie talk at CCC. It kind of rekindled my interest in the field of TR blah 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 what the fuck research. So it's also it's like worth looking at Shahar's stuff. It's also really worth looking at like the specifications, the protocols, because when you look at them, you'll just kind of cringe and go, "Oh my god, who designed this shit?" And it's also worth having a play at home. So before we begin, what are TR-WTF? They're DSL Forum specs made by a bunch of people who write specifications. They're like specs that define stuff like how ISPs should manage like CPE devices, which is consumer premise equipment, stuff that lives in your house, how they should manage it, and how they should, defines the protocols they should use for managing that shit. It's got a bunch of protocols. It's like you should implement these. It's considered best practice, and they're all shit. So today we're going to talk about TR-06 and TR-06FAIL. There's also TR-111. There's TR what the fuck. There's a whole bunch of them. They're all terrible. The specs are massive, and the implementations suck. The specifications actually suck as well. You should take a look at the specs. They're on the Broadband Forum site. So, firstly, the first one I'm going to chat to you about is about TR-06FAIL, and it's TR-06FAIL's LAN-side DSL CPE configuration. So the spec outlines this disgusting SOAP-based protocol that allows configuration of routers in people's houses and stuff, but it only allows configuration from the LAN side. So if any of you remember way back when you get shipped a router and they'd also ship you a CD-ROM with like broadbandsetup.exe on it, and you'd run it and it'd set up your router and then you'd have internet. Normally how that program would talk to the router was over TR-06FAIL. And what it allowed was the program on the end user's computer would talk to the router, configure it, set it up, all this gubbins. You put it in your account number and shit, and it'd go, okay, your router's now been provisioned, it's online, you've now got broadband, you've upgraded from dial-up. Have a good day. You can download the specification from here. It's really long, it's really dull. It's worse than the DNS or RFC, as in you will literally fall asleep reading it, and you'll also cringe a lot reading it. So 069, the other one I'm going to chat to you about, is CPE WAN Management Protocol, also known as CWMP. And it's how the ISP manages your router in your house, as in the magic backdoor that some people get really para about that allows your ISP to talk to the device inside your house, do shit in your LAN, reconfigure stuff remotely and all that. And it's now in Amendment 5. It'll probably be on Amendment 6 soon because these fucking dickheads decide to keep changing it every fucking time. You can download it there. Yeah, they They can't make up their mind as to what they want to do. It's disgusting, but you should download it and read the spec, because you'll just look at it and you go, oh my god, what the fuck are they doing? It's actually well worth a read. You'll fall asleep about 6 times reading it. So 064 is kind of cool. So according to the spec with TR-06FAIL, when you're on the LAN side, as in inside, behind that, inside the trusted LAN network of a CPE device that's got 064 enabled, you can manage it and you can get and set pretty much any settings. So it's basically full read-write to the config of the device. So you can reconfigure what ACS server connects to, which is relevant to 069. You can change DNS settings, you can change wireless keys, you can change pretty much any other configuration variable you can think of. There's fucking loads of them. It even comes with, believe it or not, a set of security requirements that are kind of outlined in the spec. So it says statements like this. Any action that allows configuration changes to the CPE must be password protected. It also says, access to any password protected action must require HTTP digest auth. Sensitive information, such as passwords, must not be readable at all. And also, it's only meant to listen on the LAN interface of the device. So I think we're going to find out, I think you can already see where the problems are going to begin. So, yeah, I mean, they've got dreams. They've got this idea of auth and, only listening on the LAN interface and probably not running as root and generally not being shit. But reality's a little different. So, the realities of TR-06FAIL is that password protected can go out the fucking window. I've only seen a couple devices in the wild ever that have password protect their 064 interface. And this was kind of a bit serious. So, password protection, oh, fuck that, that's hard. Actual credentials readable in plain text, oh, fuck yes. I mean, why wouldn't you be able to recover the wireless key? And that thing about it only listening on the LAN side of the device, well, oh no, fuck that. We'll just bind to 0.0.0.0, it'll listen in all interfaces, and it'll be fine. Nobody will ever talk to this. Oh, and it turns out that one of the implementations also stuck in a trivial command injection vulnerability that allows you to execute code as root, because why the fuck not? When you're making a fucking dumpster fire, you might as well pour in some kerosene. Maybe chuck some dynamite in to liven things up. So, obvious outcome is shit's fucked. How fucked? This shit happened. If you remember around December this year, Deutsche Telekom shot the bed and fell over, and 1 million customers were knocked offline because shit got fucked. It got completely wrecked. And this, I've no idea why the man is like poking a thing in a switch there, but the Reg picked great pictures because the Reg are great. But yeah, they got fucked because of this. And then TalkTalk got fucked because anytime an ISP is going to fuck up, TalkTalk have to join the party and fuck up even worse than everyone else. I mean, they don't like being left out. If somebody else is going to fuck up, they're like, hold my beer, I got this. Speaking of TalkTalk, TalkTalk's response to this was the single fucking stupidest thing I've ever seen. So, there's a list being passed around in various forums that shows that like 70k TalkTalk users' wireless creds were nicked. And some of this list made its way to a journalist at some point because it was being passed around. It was like, ah, lol, here's a bunch of cracked WPAs. And it wasn't cracked WPAs, they were stolen using this. And TalkTalk were like, oh no, people don't need to reset their passwords, it'll be fine. Deny everything. Which is kind of what they do, so lol TalkTalk. But it wasn't just TalkTalk. The ISP my parents used, that I grew up using, Aircom, they got fucked as well. They got massively screwed. Customers were offline, but Aircom are notoriously shit, right? Anyone here who's lived in Ireland has probably had a TalkTalk, or has had an Aircom connection at some point, or has dealt with Aircom, and knows that Aircom are a shower of shits, and they're bad at being an ISP. It's slow, it's crap, but they're better than TalkTalk, because when Aircom found out that a shit ton of their customers' password had been stolen from their devices, TalkTalk went, deny fucking everything. No, it didn't happen, it'll be fine. Aircom went and sent out a letter to everyone going, please change your passwords. So at least they're shit at being an ISP, but at least they're responsible, unlike TalkTalk, who are also shit. Post Office, Demon, a bunch of other ISPs got screwed as well. So yeah. What happened? Who did it? Where's the attribution party? Do we roll the dice? It was Iran. It was North Korea. It was China maybe. Who did it? What happened? Well, it turns out it was script kiddies. It was scrubs who wanted to build a giant botnet to packet the shit out of things so they could win an Xbox Live and lag their friends out. So, what happens is, this is the actual exploit code they used. I dug it up from a script kiddie forum. What it is, you can't really see it because it's, yeah. But what it is basically the important bit is it sends a set NTP servers command to the device. And in the set NTP servers contains backticks, which any command that goes inside the backticks gets run, because apparently it's the 1990s again, and this kind of shit's cool. So you've got the world's simplest command injection in like one of the config variables that allows, completely, running code in the device, screwing shit up, dropping your, in this case it was called ANI, but, dropping your DDoS.C botnet shit on the device and using people's connections to packet stuff, because apparently that's cool. So here's, by the way, a screenshot of the ANI nonsense, because apparently you can't do a security talk that's taken seriously without including a screenshot from IDA Pro. Because when people see a screenshot of IDA, apparently you know what you're talking about. So here's the mandatory IDA screenshot that shows it sends a fucking request that does some stuff, and stuff happens. At least that one's a bit more readable than other IDA screenshots where it's like a call graph that doesn't make any fucking sense anyways because it's too low res to see. But yeah, that's a bit of the worm that spread. So before I continue, this worm basically, it was actually, in terms of malware, is actually pretty neat. It was poorly written, but it was cool. So they'd found out about this command injection bug, the scrub lords, the script kiddies, who want to, do massive DDoS attacks, and they wrote a really simple worm that just scanned and propagated and scanned, and it also blocked further access to the TR-06 port, and it, prevented reinfection of the device. But there was a slight problem. When they infected a device, they fucked up. So when they reset the NTP server variable, they overrode it with a download and run malware. If they'd done that and then set the configuration variable back to its default setting, everything would have been fine. But it turns out that when a router reboots after shitting the bed because your malware is buggy and causes it to basically, stop functioning, and it reboots, it turns out when it tries to find out what time of day it is, and instead of getting what time of day it is, it downloads and runs malware instead, shit's fucked. Your router no longer works. Because believe it or not, routers really care about time. Apparently, knowing what time it is vitally important to routing your packets over the internet. So it wasn't even the first time that people realized that this service, this piece of software exposed the internet, which was a ROM pager piece of shit, was fucked. Previously, before TR-06FAIL, which took out Deutsche Telekom, TalkTalk, and all the other shit ISPs, we had a little thing called misfortune cookie that people actually freaked out about. And it affected the same ROM pager service, but it affected the TR-06 component instead of the 06.4. And it allowed remotely accessing the device without any authentication because it allowed this, it was this amazing bug. And some of the people here that I know of saw that talk with me, and I was taking notes during it, and I was like, holy shit. And it was basically, it was a write what where bug. You could write any value to any place in memory via this. And you could basically write, is authenticated 1 or authentication required 0 or whatever it is you need to access the device. So yeah, you can basically overwrite any of the internal state variables with the bug. And this is a snip from a proof of concept by a person called Kenzo, who also discovered the config overwrite leads to command injection bug. Some Irish chap, never met him, would love to buy him a pint, because caused loads of ISPs headaches and gave me many sleepless nights. When you send cookies like this, what it does is it tells the server to not bother checking for auth, blah, blah, blah. So the cookie name is the offset in memory you want to overwrite, and the cookie values are the shit you want to clobber it with. So it's like, this isn't even memory corruption. This is just writing memory and just doing shit. It's like the world's greatest bug. I mean, we need more of these. Yeah, basically sending that cookie to a certain device will basically turn off authentication and go, yes, hello, come in and reconfigure me. So yeah, it was like, that's kind of an idea how shit the software that runs on these things is. So I'm also gonna, you kind of get the idea of 064 is not a great thing. 069 is even funnier. So it's another DSL Forum spec. It's got like some bits about security. It's got support for TLS, and you can have authentication. They're both entirely fucking optional, because why the fuck not? The protocol's a disaster. It was designed by committee, and a committee who were like fetishizing over XML, which I think you'll get in a minute. These are the people who like wank themselves to death over like, oh, we need to put more XML in it. It needs more XML. When I was reading this, I was like, do you get off on putting like angle brackets and things, mate? Because this is seriously fucked up. Yeah, it was like some weird club of XML lovers. But so yeah, it's got like this gubbins about SSL and TLS is totally optional. Some setups are really solid, and they've got like mutual auth with like client-side certs, cert pinning, and other cool things, and some other shit just runs entirely in plain text. When it comes to authentication, it's like, that's optional. CPE to ACS usually uses HTTP basic auth, but it's not using it for authentication. It's usually using the username field as like a unique per device identifier. The ACS talking to the CPE it's quite often I've found it's TLS with like a client cert, but if TLS is hard and Scott Helm hasn't given you a workshop on how to do TLS securely, you might instead be using a shared secret, because why the fuck not? Because that's totally safe and not completely fucked. TR-06FAIL, as I said, it's full of XML. It's got stun, it's got SOAP, it's got XMPP, it's got UPnP, it's got basically, if you can think of a protocol that uses XML, they will probably fucking include it in this specification, because they're like, yes, more XML, yes, job security. So it's fucking disgusting. You've got like, I mean, why does your router need to have a Jabber client to do configuration? Why does it need stun, SOAP, and XMPP? I don't even get it. There's enormous attack surface there. I've barely scratched the surface of this attack surface, and it's pretty fucking grim. You know, I've looked at a tiny bit of it, and if you look at it, you'll find something wildly different, and you'll come up with a whole new bunch of outages that, you know, will allow you to take over ISPs. Also, we can make the assumption the CPE end, like the embedded device that lives in your house. I've spoken about embedded device before here. They're crocs of shit. You know, embedded devices just generally tend to suck. So I'm not going to carry on about those. We know your router is insecure, but what about the ISP? So surely, even though your router sucks, your ISP, you know, BT or TalkTalk or fucking whichever crowd that you're with, they mightn't be very good at shipping you a good router, but probably their management server, it should be super secure. You know, surely they're not that irresponsible and shit. Surely it's also rock solid enterprise software, because only enterprise software uses XML, right? It's enterprise. Surely it's good, and it's got support contracts and not terrible. And surely it's not that bad. I mean, we wouldn't be using this management protocol if it was shit, right? Surely we'd be using something better. But yeah, you know, surely it's all fine, right? Yeah, and this transitions into the second act, where we show you that that's a load of bollocks and that we can actually hack the planet. And today, for free, you can make yourself a ginormous fucking botnet if you want, or you can hijack loads of shit, and I'm going to show you how. So, I was thinking about threat models when I wrote this talk, and what we want is, you know, we want world domination like Pinky and the Brain, right? And we want to pwn like millions of routers all at once, and we want to do it really quick, and we want to do it really easy. So, we're not really inclined to like hack them one at a time, right? Like the thing Annie did was it hacked routers one at a time by being a worm and doing it en masse, you know, but we don't want to do that. We're too lazy. Writing a worm's hard because, you know, you don't want to fuck it up, and, you know, writing a worm is generally just a pain in the ass. So we don't want to do this shit where we scan the planet and hack everything. We want to hack them all at once. We want it cheap, we want it easy, and we want it now. So started auditing ACS servers. These are the management things that manage your router. And because I said to myself, well, why the fuck would I hack like a billion routers one at a time when I could just hack the server that manages them and then manage them myself. It made more sense. So I've been like auditing these in my free time. It's gone slowly. Yeah, there's a lot of shit because there's a bunch of different ACS implementations, and the ACS is the device that manages the devices. So it's like pretty much as is. It's like the best botnet command and control panel you've ever met because it's designed specifically for managing shit, and it's also glorious enterprise software, and you don't have to write it yourself. So yeah, I'm gonna tell you now about some of the shit that I found. It's pretty grim. Buckle up. So far. This is actually an incomplete list. I've fucked up FreeACS, OpenACS, LibreACS, and I've also fucked up a PHP CWMP library, which allows you to build your own ACS server in PHP because everyone wants to do that. And I also audited a thing called Perl CWMP, which is another open source ACS implementation written in Perl because why the fuck not? Because apparently we have to write, if you're going to do shit with XML, you have to write it in Perl or Java or PHP and not in a good language. So, yeah, some work has been done here. So, firstly, I'll talk to you about FreeACS. The disclosure timeline for this was, fuck disclosure. It was, at some point when I was bored, I found some bugs. Between then and April, I worked on weaponizing these bugs to turn them into a super reliable remote exploit that would do the things I wanted. And then I was like, should I tell the developer? And I went, no, because I've had to deal with this fucking developer's code for like a while, reading the shit. He doesn't deserve any more of my time. In April, I publicly disclosed it, and currently it's still unfixed. And I think you'll get why I wasn't fucked dealing with this developer in a bit. So yeah, FreeACS, it's been around for a while. I actually think it's just maintained by one person. It uses Tomcat and MySQL. You know, it's proper enterprise shit. It's written in Java. So it's definitely safe. It's rock fucking solid Java. I think it's actually maintained by one person. There may be a small group involved. Yeah, it's a piece of shit. So, it builds itself as the most complete TR-06FAIL ACS available for free under the MIT license. And I'm like, that's a really specific claim to make. You know, it's like, okay, buddy. You know, it's like, the most complete TR-06FAIL ACS available for free. Okay, under the MIT license, it's like, well, what if one's under GPL and it's also the most complete? What if it's more complete? But what also this means, most complete means the most attack surface, right? If you've gone ahead and implemented all the things, you probably fucked all the things up pretty badly because you've stretched your resources too thin. It's like attack surface on top of attack surface, and I've barely even scratched like a tiny corner of it. So, again, why did I audit FreeACS? Does somebody see something wrong with like the installation instructions here? You know, like, how about we do this thing, you know, getting some shit from the internet, you know, without like SSL or nothing, and then just run it as root because YOLO, why the fuck not? Seems like a really great way to deploy software, right? And then it's like, oh, by the way, our setup script is so shit that it leaves you some shit to do yourself because we couldn't write a good one. So when I saw that, I was like, this is going to be bad. So, firstly, the lowest hanging fruit. You can log into a shit ton of these things using admin/xaps as the login credentials. You can show down the fuck out of them with entitle FreeACS, or you can Google with FreeACS web, because apparently it's not just a web, it's a web. I'm surprised they didn't just call it web, because then we could have www. You can also find them on Census, Bing, you can scan some ports, you can use Binary Edge, which is fucking amazing, and find them that way. Yeah, just use whatever discovery of shit in the internet platform you like, and you'll find some of these things. And you'll probably be able to log into them because nobody changes the defaults. But let's say somebody did change the default password from like XAPS to like password 1, and we couldn't figure out the password. We have to hack them another way. We have to think differently. We have to try harder. So when I started auditing, I was like, I'll log in and see what gubbins it is. And it's like an XSS testbed with an optional ACS server. it's like Hack Me Bank or some shit, but it's like XSS platform. Now, these are all post-auth bugs, so I don't really care about them because they don't allow us to remotely pwn the device. But it gives us a good idea about how shit the software is. So here's some screenshots. So here we have an alert box. So yeah, there's some XSS. There's some glaringly obvious XSS. Whoops. Yeah. So yeah, we've got alert boxes. And then we have more alert boxes. And then I had to start numbering my fucking alert boxes because there was too many alert boxes. I mean, when it comes down to putting numbers in them, just so you can figure out which fucking one is which, it's pretty bad. So, I didn't want to rely on post-auth bugs, though, because then we'd still have to rely on, like, default creds. And, I mean, while the cross-site scripting is pretty funny, I wanted something else. I wanted remote. So it had to be exploitable over the internet. And I wanted admin access. I wanted privileged access. And I also want it to be really easy. Because you want to do this cheap and you want to do it easy, right? You want to build your giant packeting botnet so you can knock kids off Xbox Live, and you're probably about 12. So I didn't want this to be a particularly hard thing to do when I was looking for these bugs. So I was looking for like the easiest bugs, the really simple ones. So it was cheap and easy. So the PreOp Attack surface is fucking massive. And when I was thinking about this, the easiest way to attack these things is to take the position of a router talking to the configuration server, because you're shitting tons of XML bollocks back and forth, and there's loads of shit going on, and there's going to be something there, because that's like an unauthenticated attack surface land. So when I started auditing this, I was like, well, I'll take a look and I'll see what is the first thing the router sends to the device. What does it do? And the first thing a router sends in TR-06FAIL land is it sends what's called a notify message. So when the router connects to the ACS, it sends a notify, and it's like, yes, hello, this is router number blah, blah, blah. I'm ready to be configured, my friend. And it's a big blob of XML shit. So I was like, well, let's look at that, transaction. Let's look at that, because that's probably got some shit in it. And this is what it looks like. And it's a disgusting shit pile of XML. And I don't like XML, and I want to curl up in a corner and cry. And I went to the pub. And I just didn't want to have to deal with this, because fuck no. Can we not just all switch to JSON? And I'll be a lot happier. So yeah, I was like, oh, that looks grim. That looks pretty bad. What am I going to do? I'll fuzz it. So I tried, but I caused the parser to shit the bed, and, the ACS server would fall over a lot and stop working. But I got bored because I didn't want to have to write any more XML test cases or write any more shit that dealt with XML for a bit. So I was like, hang on. What else? I've looked at the XML, but there's some other gubbins that the router sends to the thing that the thing accepts and it does transactions with. So I had a look again, and I was like, so the screenshot I showed a couple minutes ago, that's the XML, but what's missing is the authentication. So sometimes when you talk to the ACS, you include like a basic auth header, which the ACS uses to identify the device. And I was like, hang on, it must do some gubbins with the identifier thing. So I thought, I'll chuck something in the basic auth header, and it was one of those decisions that, you just come to, and it's like, I'll try this. It won't work. Oh yes, it did. So, yeah, the username field in the basic auth header is used to denote what device. It's like a unique ID or some bollocks. So I was like, well, it must do something with this unique ID. I'll just chuck some shit in it and see what happens. And I mean, basic auth is pretty loose as well. Like, you can stick whatever the fuck you want in a basic auth header and it'll be fine. So, yeah, some stuff happened. I stuck a single quote in. And it fell over. Because the basic auth username goes into a SQL query with no sanitizing. And my SQL goes, no. No, mate. Not doing this. The problem is there's like some shit, like there's what I thought was a character length limit, but it's like some shit gets truncated. So I couldn't put a good SQL query in. I could break things. If I shut out this request at all the ACS servers running the software, they'd just cease functioning. And they'd have to flush the database and rebuild them. somebody might be able to like write a really small SQL query and sneak it in there, but I didn't want to have to go down that route because again, our threat model's a 12-year-old, right? So we can kill the ACS by causing it to do a broken SQL statement forever. But then I looked at it again and I was like, okay, that username field, it's using an identifier, it's unsanitized clearly because I can chuck in a single quote and the thing stops working. The username also shows up in the user interface a shitload. When you're logged in as admin and you're doing admin things, the username is there. And I was like, what if I could get some stuff, like an alert box in there for shits and giggles, and make it come back out as the logged in admin. And maybe we could get some XSS and then maybe exploit some of the other side of it a bit. Maybe. And just for the record, up until about 6 months ago, I thought cross-site scripting was like one of the least useful bugs in the world. And then I did this. So we've got persistent XSS on the admin side out of this pretty easily. It worked. We send a notify message as an unauthenticated device, and because lol, why the fuck not, whatever script tags we put in come out on the admin side and run with the admin session, and only will run if the admin's logged in. So we've got some limitations, like we've got a limited character length, blah, 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 but yeah. So it worked. This is another alert box because we're living in the land of alert boxes. And then I thought to myself, can I inject a remote script so I can do more shit and get around the char length limitation? Yes, I can. So what happened next was, okay, you can get JavaScript to run inside the admin session. So I thought to myself, I could either write a big blob of JavaScript to do some shit, or I could just write some small bit of JavaScript by copy and pasting from Stack Overflow because my threat model's a 12-year-old, and just add a new admin user by sending a post request. So I looked at this, and yep, there's no CSRF or XSS protection or whatever the fuck. So we go to Stack Overflow, we copy and paste an XML HP request example, and we make ourselves a nice payload, and it works. So I wrote a really, really simple script that automates the whole process. It spins up a local web server that serves the JavaScript, injects the thing when the admin logs in, the gubbins happen, and then you have an admin user added. So, yep, it adds a new user remotely. So you can just shit this little HTTP request at any ACS server running FreeACS, and the next time the admin logs in, you'll have an admin user at it with whatever username and password you want, which in this case is hacker. And for debugging, I put in loads of alert boxes to tell me what the fuck is going on. So I could debug my shit copy-pasted JavaScript. Because I literally said, I'm going to Stack Overflow this exploit. You know, I'm going to literally copy and paste all the bits and put it together because I was emulating the threat model of a 12-year-old. And I was also possibly drunk. But, you know, whatever. So yeah, we can add a new admin user remotely. And we can then log in and we can manage all of the shit. But that's just FreeACS. So what we can do is we can scan the webs or Shodan, Google, Census, whatever the fuck, find all the FreeACS servers, spaff some notify messages, take over them, and start managing people's ISPs for them because they're clearly too fucking incompetent to manage it themselves. So, yeah, we just spaff it out at the internet, and then we wait a bit, and then we're now the ISP for millions of people, potentially, if you go ahead and do this. Don't, though. There's a thing called the Computer Misuse Act, and you probably shouldn't do any crime. Maybe. So yeah, you could easily hack the planet and you could take over entire ISPs in one shot. One post request, millions of devices. It's like the cheapest and easiest win you can ever have. It's beautiful. So I thought to myself, well, not everyone's using FreeACS, so I decided to look at OpenACS and LibreACS. Now it turns out that LibreACS is a fork of OpenACS because, yeah. So I started auditing these, and they didn't fucking work. I mean, they just literally, the software was so terrible it wouldn't run. So I eventually got them running, and, you know, I set them up as per documentation, and then I started fuzzing it a bit, and then I thought to myself, wait, this is really shit software that barely works. I should examine the configuration of it. And, well, Yeah, because lol, Java, JBoss, Enterprise. On a default install of Libre and OpenACS, you can just remote root the fucker with like no auth and no time and no effort, because they leave JMX console, web console, and the JMX invoker circlet thing open. And it also leaves the MySQL root password blank for no reason. So you've just got like code execution on top of your code execution, because we like to put bugs in our bugs. So I thought to myself, I'd look at some more interesting shit, and yeah, you can just remotely root the fucking things. I just used like a public JBoss exploit, and boom, you pop them, game over, wrecked. So are these in the wild? So I decided to do a scan, and I actually found that this shit does live in the wild. These things actually exist on the internet. They're connected, they're hooked up, they manage millions of things, and you can just pop them with no effort. I stopped looking though, because I said to myself, I do not want to go to jail for accidentally pwning a bunch of ISPs. You know, that's like a thing where your charge sheet would be a library long, because they probably do you for every single device you could have popped. So I thought, fuck this. So some of these I've notified a couple of ISPs, and a couple of them said they're going to replace their ACS server, they're going to lock it down or whatever. They probably won't. So I wanted a break. No more Java for me. So I thought I'd look at an ACS written in PHP, because, you know, we're going to go to another enterprise-grade programming language here. And I found one. Somebody wrote a library for writing your own ACS in PHP, and it's called the PHP ACS, blah, blah. It's some shit in Laravel. It's PHP. It's disgusting. You shouldn't go near it. You should reconsider your life choices if you're using it. And I started grepping, and basically this happened. So, yeah. It's like, yes, hello. I would like to unserialize this user-submitted data all the time, repeatedly, over and over again. Is it exploitable, though? I mean, when it comes to PHP and unserialize, you know, it can be a pain in the ass. But with Laravel and Composer and shit, you've got this wonderful thing called auto-loading. So, like, it's really easy to find a reliable pop chain in this, because it auto-loads a whole bunch of shit that provides you with, like, serializable gadgets. So it's really easy. Otherwise, you can do, like, how those guys pwn Pornhub for, like, the 10K bug bounty and find a memory corruption. But that's, like, hardened stuff. So, like, if you want to do that, that's fine. But, like, it's way easier just to build a pop chain. If you use this library to build ACS, you're going to get fucked. Game over. You know, you're just screwed. So, finally, the bug of today, and this one has a pint challenge attached. So, there's a little Perl project called Perl CWMP. And if a person get a code execution from this bug, I'll buy them a beer. Because I have not yet gotten code execution from it, but I know it's possible. So, I started fuzzing this thing. This was like, you know, I was like, this looks shit. It's Perl. People can't write Perl. And the problem is, when you're auditing software written in Perl, Perl's a write and execute only language, right? When you write some code in Perl, nobody else can fucking read it. They can run it, but they can't read the shit because it's Perl. So I found this really interesting bug within like 10 minutes of fuzzing. So what the bug is, it's actually a really trivial bug. So one of the fields you send, it's a directory traversal bug that does create directory and create file. So you can traverse, and because the shit runs as root, because why the fuck not, you can create a directory with any name you want anywhere on disk, but you can also create a file anywhere on disk with a mostly user-supplied file name. It'll be whatever the fuck .yml. And you can put that anywhere on disk that you want. And it'll contain some contents that you can control and some contents you can't. Now, I tried dropping it in cron tab, like tried chucking it in cron hourly, but I ended up finding an interesting thing about that, which made it unexploitable that way, because it turns out cron ignores files with dots in them. And I ended up finding on the Debian bug tracker, a like entry going, oh, yeah, cron ignores files with dots in them because the POSIX standard is retarded. So we can't use cron. But I'm sure you can find other ways. I've gotten code execution in some cases where there was like a misconfigured web server that allowed double extensions and shit. But I'm sure somebody here can find a way to reliably exploit this bug, and then I can buy them a pint. Or 2 pints, or 3 pints, or depending on how elegant your exploit is, multiple pints. But yeah, it's a really simple bug. I'll chuck the proof of concept up somewhere. I forgot to put it online before the talk, but it's a really trivial exploit. And surely we can do something good with this. Again, you can create this is remote file creation bug in that ACS software. It's just Perl-CWMP. You can find it in GitHub. I'll put up the XML shit that you send to it that makes a directory and makes a file. But yeah, somebody here, please fucking find a way to exploit this so I can buy you beer. Because it's exploitable, but just not quite. But yeah, that's the Perl ACS bug. It's really weird. Look at it, and you'll come away going, no, Perl, please stop, make it stop, it hurts. So yeah, basically the serial number parameter in the XML shit that you send, you just put it as like ... wherever the fuck you want to clobber, and boom, it happens. And if you send one with like that, temp test, it'll create a directory called temp test, and it'll also create temp/test.yml. I've tried new lines and shit, and Perl's just like, YOLO, I'm going to stick them in the file name, and it'll be fine. Because apparently the POSIX standard file names is really loose. So yeah, somebody find a way to exploit this, please. It's going to drive me fucking mad, and I'd quite like to sleep at some point. So yeah, we also control other variables, like the manufacturer, product class, and OUI. Whatever shit we put in those ends up in the file as text. So that's the right stuff in the file that you control. I've managed to create a valid shell script inside the file that when you run it with bash, it'll run code, which wasn't very hard. But I haven't managed to find a place to put the file that'll get run yet, because cron ignores it. So somebody somewhere is going to figure this shit out. Somebody, please do. Think of it as like the CTF challenge or something, because it's really annoying and weird. So yeah. What we can do when we pwn an ACS, as I may have said before, if you pop an ACS, you control all the shit the ACS manages. By which I mean you can like do stuff like reconfigure everyone's DNS settings and suddenly do like a mass farming attack and redirect Facebook to Goatsy, which would be pretty neat. Or you can like reflash the firmware in all the clients, so you can tell the clients to send you their current firmware, backdoor them and send them back. So you do a mass persistent rootkitting. And if your rootkit did some sneaky things, it'd be pretty hard to clean up, as in you'd have to replace all the devices. How much does a router cost? Multiply router cost by TalkTalk customers, and you got how much money you can cost TalkTalk. That's the kind of problem we've got there. Or we can fuck with billing, we can provision new shit, we can do whatever we want. We can change people's firewall settings. We can make NAT not NAT. One of the things that I came up with when I was chatting to a mate was we could do this. We could hack the ACS using the exploits that have been provided. Once you use that, you could then tell all the devices to give you their firmware. You could backdoor them, and then you could shit them back. And if your backdoor made the devices no longer actually deal with the legit ACS and actually talk to a sneaky one, you could like switchy changey. So you could make the ISP admin think they're managing shit when they're not, and you're managing shit. You could do loads of crap like this, and you could just take over countries and, you know, manage a country's intranet because you like pain and, you know, doing customer support, apparently. So yeah, it'd be pretty simple to like take over things, and you could probably find a way to profit from it, or you could just set up a call center and become an ISP yourself, just like the most hostile of hostile takeovers. So yeah, go forth and have fun. I'm just going to make a brief note about the so-called defenses that service providers use to protect their ACS servers. Some of the things they do is they restrict access to the ACS servers, so only people on their customers' IP address ranges can talk to it. That's bollocks, because we can just hack one of their customers and pivot. Or we can put it on a management subnet, so you have to break into a router to break into the ACS, to break into all the other routers, but given that routers are shit, that's easy. Or we can use client-side certs and mutual auth shit, but then again, we just have to pop one of the routers once, and they're fucked. If you layer these mitigations, you can actually make it kind of difficult to talk to your ACS, but not impossible. So you can make it just high enough that the 12-year-old who wants to build the biggest DDoS botnet ever will fuck off and do something else, like go outside. Maybe. I've met some pretty determined script kiddies. So, yeah, I mean, there's defenses. The only good defense, in my view, is just fucking scrapping it all, setting it on fire, and not doing it. Let people manage their own shit, or using SSH or something that's not crap. But this XML bollocks can go fuck itself. So yeah, what's next? I have a bunch more work to do, and I'd like people to help. There is a lot more shit ACS servers people use that I think we should be auditing. Genie ACS, FreeACS-NG, there's the Draytech ACS, there's Cisco's ACS, which apparently has been like end-of-lifed, so it's probably fucked and in production everywhere. Auditing more CPE devices implementations, because I've only audited ROM pagers so far, because it's the most common, but I found out that Orange, the telecom in France, they've open sourced their like endpoint ACS TR-06FAIL client gubbins, so I need to audit that. It's written in C and it looks disgusting. But also, we should look into, like, I need to take a look again at TR-111, and that's, let's put TR-06FAIL inside your Internet of Shit. So let's remotely manage your smart TV. And that's what this is for. And it basically means once this gets rolled out, and it's getting rolled out, I've seen implementations in a couple of places. BT or Virgin or Sky or whichever cunts provide your TV and your internet at the same time, because you probably bought a package deal, they'll be remotely managing your television as well as your router. And that's very uncool, because they're going to be managing your television as well as your router with this XML SOAP shit. So yeah, you can probably, in a year or so, you'll probably be able to hack smart TVs with this as well as routers. And you probably, further on from that, be able to hack people's toasters or whatever we put in the internet next. Because apparently everything needs an IP address. So yeah, no, there's a lot more work to be done. There's more shit to hack. Finally, I'd like to just thank the SteelCon team, people who've done previous work, like Shahar, Kenzo, a couple people. Like to thank CyberGibbons and Ken for Pentest Partners, because when I started looking at this, I had a chat with them and we had some useful bouncing ideas back and forth. I'd like to thank the DSL Forum for writing such a shit spec and designing such a crap thing that it gave me stuff to do and talk about. Vendors and shit for keeping me in a job, and you for putting up with me talking shit for like an hour or however long it's been. So yeah. If you want to subscribe to my newsletter, you can contact me on Twitter, Jabber, or email, which I'll ignore.